Welcome everyone to my channel Code with Ease by Varsha. So today, as part of the design pattern series, we are going to discuss strategy design pattern. So here's what we are going to cover today. First, we're going to start with a real world problem and then the code for that. Then we'll see what are the problems with that existing code. What is strategy method design pattern? How does strategy pattern help? And then the optimized code for that. What is the problem that a strategy pattern is trying to solve? When should you use strategy pattern? Then we'll discuss a few real world use cases. We'll see a practice problem that you guys can solve. And then we'll wrap up with a quiz at the end. So let's say you are planning for a trip and you need to pack clothes for that, but you need to pack different set of clothes based on the weather that you are in. So if it is weather is sunny or if it is raining or if it is cold, so you need to pack different set of clothes depending on the weather scenario. So if this is the problem for us and we need to write the code for a planner class, okay, like a travel planner class. So let's see how do we write the code for this. So here's the sample code for our requirement that we have a travel planner class and we have a destination and weather conditions. So I've just written the constructor that is going to initialize your destination and the weather conditions. Now I have to write this method called pack clothes. Now pack clothes will be the method that is going to be called again based on your destination and the weather condition. So what is it I'm going to check first? So of course, if I have to pack different set of clothes, I'm going to give a couple of if conditions. So I will just say, okay, if the weather conditions, let's say it equals summer, or I can say sunny. If it's weather is sunny, then what am I going to pack my clothes for? So I can just say packing t-shirts, tops, and shorts for that particular destination. So I'll just print out the destination, right? Now this is one condition. Else if, let's say if the weather is, let's say the weather is rainy, so I can just say weather conditions dot equal ignore case that if it is rainy, then what should I pack in? I should pack in umbrellas and raincoats. Now, what else can be? I can also pack for something which is cold, a hill station kind of a thing. So I can again say else if weather conditions like is equal to cold, the weather is cold, I can say for that I need woolens. So I have to pack my gloves and woolens. And just else statement that if none of them matches, I can just say it's invalid scenario or something. Anyway, so the point I'm trying to make is based on a weather condition, I'm changing my strategy of packing the clothes. If it is sunny, I'm going to pack t-shirts, tops, and shorts. If it is rainy, I'm going to pack my umbrellas, raincoats. If it is chilled, it's cold, I'm going to pack my woolens. So this is what I meant when we said strategy. Okay, different strategy for different weather conditions. So over here, what I can do is let's try to create the planner. So my planner is travel planner. And now I'm going to initialize my weather and my destination. So let's say I'm going to Rajasthan as the destination in India. And we know that it is super hot during this time. So now what can I do? Travel planner or pack clothes. So this is one object that we created for a travel planner class. And then we created another travel planner class. And let's say now I want to go to a hill station. So I can say, let's go to Sikkim, although it's not a good idea now. We recently had an avalanche. So it's cold, not pack clothes. Now, I know by this point in time, you guys have realized there are a lot of flaws in the code and this is not the right way to plan the vacations or the trips. But I'm just writing the bare minimum code that, like the brute force code, you can say, one can write for a travel planner. So now let me execute this. So this is what we get in the output, packing t-shirts and top for Rajasthan, and for Sikkims, we are packing the woolens and gloves. So this is just the initial code that we are going to write based on the destination and the weather conditions. Now let's jot down what are the problems that we have faced in this. So here are the problems that we can see with this code. First of all, it's a lot of code duplication that is happening. The reason being, when we go to this class called travel planner inside the pack clothes method, for every weather condition, we are kind of duplicating the same kind of code because it's just that the weather condition is changing. So that is one issue. Secondly, there's a bit of rigidity, like the coupling that we say. A lot of high coupling is there between this main class and the travel planner class. If tomorrow I change my packing strategy, the way I'm packing clothes, if I'm changing any of the methods, I have to come back to this main class and I have to change all the objects. So that is about the coupling. And because of this only, there's a lot of inflexibility, right? So there's low flexibility in this code that tomorrow, again, if I have to add new weather conditions, you have to add the destinations, not destination, but at least the weather conditions, we have to remove something. Again, we have to change the existing code. So this is violating one of the solid principles called the open closed principle. For coupling, again, because the class is having too much responsibility, the travel planner class is having too much responsibility. This is also violating the single responsibility principle. Okay, too many things are going on in this class, so it is violating single responsibility. So it is violating single responsibility principle. It is violating the open closed principle of solid principle. So these are some of the existing problems that we can see. What can be the better way of solving this problem? So let's find it out. So, like we saw, what are the problems with existing code? There's a lot of code duplication that is happening in the travel planner class. There's a lot of coupling between the travel planner and the main class. Lack of flexibility because of the second reason, and limited reusability because I cannot give any reusable component of my packing strategy, of my packing logic to be used somewhere else in the application. Too much information already coupled inside the travel planner class. I cannot reuse anywhere anything else. Okay, because tomorrow if I want to use this packing strategy based on weather in other parts of the application, I will not be able to use it. So these are the problems. Now here comes the strategy design pattern. This is a behavioral design pattern. So design patterns, like I mentioned in the very first video, there are three types: creational, structural, and behavioral. So we have already discussed two of the creational patterns earlier, the factory pattern and the builder pattern. So today we are discussing the behavioral pattern because this, okay, creational design pattern talks about how the objects need to be created, how they should be created. Now, behavioral design patterns is no longer talking about the objects. It is no longer talking about the travel planner objects that we have created. What it is now talking about is the behavior of the objects. Like behavior as in the communication between the objects, how it should be now. Okay, so that is what strategy design pattern is about. So it enables the creation of a set of interchangeable strategies and then encapsulates each one of them as a blah blah. Okay, so basically now we are going to see how every strategy that we are taking for packing clothes can be encapsulated, meaning it can be separated out of the travel planner class. Because tomorrow, if I'm changing any of the strategies, adding strategy or removing strategy, the class should be flexible enough to incorporate that. So that is what strategy design pattern deals with. And then this is useful when there are multiple algorithms to solve the problem. Like we have seen, if I have to plan for a trip, there are so many different strategies. So weather conditions need not be confined only to sunny, rainy, cold. There can be so many different variations of weather. India as a place has diverse set of weather conditions across the landscape, right? So there can be so many different algorithms that can happen. And depending on that, my way of choosing the travel, my way of packing my clothes will be very much different. So how am I going to incorporate that? With our existing code with so many if else blocks, it is practically impossible. So that is where the strategy design pattern comes into play. Now, how does strategy pattern helps us? Okay, technically, how does it help us? It will define a common interface or a abstract base class that will encapsulate the operation. So there will be one base class or an interface that we will create, and that will contain the operations that the client code has to perform. That is number one. And then every algorithm will be separated out. It will be implemented as a concrete class. Like in Java, we know there is an interface, and then we have several concrete classes who are implementing that interface. So every algorithm, every behavior, okay, mind it, strategy, the word strategy, the word algorithm, the word behavior can be used interchangeably. They mean the same thing. So they will be now, every algorithm will now be implemented as a separate concrete class so that it will, be in line with the interface that we have created in point number one. And now this is going to create a family of related class. All these concrete classes will now be a family of related class that can be used depending on your input data, on your problem, whatever. When I mean a family, this weather condition related packing is just one family of classes: cold weather, rainy weather, a mix of rainy and cold weather, so many different things. But all of this coming together as different concrete classes form a family of what? Weather condition based packing strategy, right? So that is what we mean by the family of related classes. And finally, this is going to give us a more flexible way and reusable way to implement the complex behaviors, because we can add in a new strategy whenever we want, because now it is a concrete class. We're going to see that in the code. We can remove strategy out of it whenever we want. It's not an issue anymore. Now let's see what is the optimized code now by applying the strategy design pattern. So now let's see what is optimized code. First of all, like we said, step number one is to have an interface or abstract base class, which is going to tell what is the strategy about. So now our strategy was revolving around packing. So we have a strategy interface called packing strategy, which is having an abstract method called pack clothes based on the destination input. Now this packing strategy will have its own concrete classes. What will the concrete classes be about? Of course, based on the weather condition. Sunny weather packing strategy, rainy weather packing strategy. So those will be the separate strategy classes that we are going to create. Let me create one now, for example. So I will say sunny weather packing strategy. So this is the class, and I'm going to say implements the packing strategy interface. Now, when it is trying to implement, of course, when it's trying to implement, it has to implement the abstract method also. So it is going to implement this method called pack clothes. And now inside this, whatever we're writing in the travel planner class, that is what we are going to just copy paste over here. That we will say packing t-shirts, tops, and shorts for this destination. Similarly, I'm going to create the packing strategy classes for rest of the weather classes. Okay, so I've created all the classes for based on the weather condition, the packing strategy classes. Now, if I go to the travel planner class, of course, this if conditions we have to get rid of. So let me remove all of that. And what will happen over here? So in this case, what is going to happen is we are no longer going to have the string weather condition. So this is also gone from here. So what are the changes I have to do in the travel planner class? First of all, I have to incorporate a construct. I have to get an object of the packing strategy. Okay, so I'll just say private packing strategy and then packing strategy, whatever the packing strategy is going to be. And that is what I'm going to pass in over here. When I'm going to create an object of the travel planner, I'm going to pass in whatever strategy I'm picking. So this aligns with our point that we were trying to make, that based on the required algorithm or based on the required strategy, I can keep on changing my objects. So I'll just initialize this. Now over here, what is going to happen? If you see, all the strategy classes are also going to override the pack clothes, right? So when I am inside my travel planners pack clothes class, I just have to call the packing strategies dot pack clothes based on the destination that it is given to us. So I'll just pass in the destination. So I'll just remove this instance variable called weather conditions also. So I'm just going to call the respective concrete class of the packing strategy again, which is going to come in from my constructor. So this is the change I'm making in the travel planner. Now let's go to the main class and see how we are going to modify now. So I'm going to copy this thing first, the object that we created. Now let's create a travel planner optimized object. And over here, now I'm going to not pass in the strategy, now pass in the string. Now what I'm going to say is new, it is Rajasthan. So I'll say new sunny weather packing strategy. Okay. And now I'm going to call the pack clothes on this. So ideally, if I run this, I should also get the same output like we got earlier, packing t-shirts, tops, and shorts for Rajasthan. So let's run this. So here we go, packing t-shirts, tops, and shorts for Rajasthan. Now I'll again copy this and I'll pass in a new packing strategy. Same for Sikkim, I'm going to pass in now. Or maybe I can do for Ooty because that is also a hill station. Now I'm going to pass in the rainy weather strategy. So here we go. Here's the travel plan for Ooty, umbrella and raincoat for Ooty. So this is about the optimized code where we have created an interface for the packing strategy and separate concrete classes based on the weather conditions. So what are the problems the strategy pattern is trying to solve? Basically, there are three needs that the strategy pattern is trying to solve. Firstly, like we said, the weather condition based packing strategy, they are a family of strategies. Just that the weather condition is changing, but the core logic remains the same. So when we are using strategy pattern, what we are trying to address is we're trying to separate a related family of classes from the client code. Who is the client code over here? The main class. Now the main class doesn't have to worry about passing in the weather conditions. What it can use is it can just simply call the respective packing strategy class. So in that way, we have encapsulated all the related family of classes or the algorithms, whatever you can say, from the client code. Like the client code is completely separated from there. The packing strategy interface has come in between. And as a result of that, there is the need to make this entire process dynamic, that I can add in new strategies, new weather condition based packing strategy classes whenever I need, or I can remove it or I can modify it. That independence is now there with the without worrying about the client code. And again, because of all of that, we have been able to achieve this code reusability and reduce the duplication of so many number of if else statements that we were writing in the earlier code. We don't have to do that. Now it's much cleaner, more flexible. That's much cleaner, more flexible way of code that we have written. So the most important thing is, how can you understand when do you have to use the strategy design pattern? This can be sometimes confusing to people. So the first and foremost is if there are multiple algorithms to solve a problem. Now, when I have to pack my clothes, if I give the example, if I have to pack my clothes for a trip, what I have to take into consideration the weather condition. There are diverse set of weather conditions. So there are so many types of weather conditions. There are multiple algorithms to approach this problem of packing the clothes. So this is the one reason that we have been able to use this. Secondly, the choice of algorithm depends on the input data. The destination is going to drive the factor what is the weather condition is going to be. So that is another hint or an indication that you have to use strategy weather, that you have to use strategy design pattern. Thirdly, like we said so many times, the need to add, modify, remove algorithms as and when needed without affecting the client code. I can add new weather conditions, I can remove it, I can modify. So I don't want to affect my main class on that, right? Tomorrow, if I remove that rainy weather strategy at all, completely from the code, I don't have to worry about anything to be changed in the client code. Next is the algorithms if they need to be reused in different parts. Okay, so this is like the fourth point is mainly about if you want to tomorrow use this rainy weather packing strategy in some other parts of application. Now you don't have to, you can just simply call that concrete class the rainy weather strategy class and use it wherever you want. So these are some of the hints or indication that you have to keep in mind when you have to decide whether you have to use a strategy design pattern or not. Now, coming to the real world scenarios. So, we discussed about this travel planner example right now about the strategy design pattern where we use. But apart from that, what are the other places where this design pattern can be used? In payment processing, when you have different payment methods, like we know when we do this shopping cart checkouts, right? We have an option to do cash on delivery, or we have credit card, debit card, UPI. There are so many different modes of processing payment. Now, the way the each of them works, the way in each of them processes the payment is completely different. So this is again an example where the strategy pattern, multiple algorithms. Okay, like we have said in the previous slide, there are multiple algorithms. It can change based on the user input. There might be need of removing or adding. Tomorrow, if I don't want the UPI method to be in my payment processing system, I can remove it. So this is one example where you can use. Secondly is the sorting algorithms. We know there are so many types of sorting algorithm. There's quick sort, merge sort, bubble sort, insertion sort. Every sorting algorithm has a separate logic. Now, if I am giving you an input data set which is very small, so I might go for a insertion sort, let's say. But if I have a large data set, do I want to go for insertion sort? No. I might go for merge sort. So my input data is driving what sorting algorithm I'm going to pick out. So this is an example where again the strategy pattern can be used. Coming to the practice problem, like which we discussed at the beginning. So this is the payment gateway system that you have to implement. In this, what you can do is you can allow the user to give in all the payment details, the amount, the method, and the billing address. Now, the payment processing that we were talking of in the real world scenario slide, there can be different payment processing. So you can do one thing that you have to consider that the algorithms for payment processing should be interchangeable. So I can choose any of the algorithm. So you have to design it in such a way, let's say you create an interface for processing the payments and then you create the concrete classes. So that whenever user chooses credit card or debit card or UPI, that particular algorithm should come into play. So this is what you can practice to understand the strategy pattern. So time for the quiz. The first question is which of the following is an advantage of using the strategy pattern? It simplifies the code by reducing the number of if else. It allows for more flexibility in selecting different algorithms at runtime, or creates a tightly coupled relationship between the context and the strategy classes. So you can comment down your answers for these questions that we have in the quiz below. So moving on to the next question, in which situation strategy pattern is most appropriate to use? So these are the options: when the behavior of object needs to be changed at runtime, or if there are multiple objects that share a common interface, or when there is a need to implement complex algorithms that require different approaches. Moving on to the next and the last question, which of the following is a key feature of the strategy pattern? It allows for easy substitution of one algorithm for another. It provides a clear separation of concern between different parts of the code. It is useful for creating complex object hierarchies. So that is a wrap for today's session. Thank you so much for watching. Hope you guys have found this session useful and informative. And if you did, please consider giving a thumbs up and subscribe to this channel for more content like this. Thank you again. See you in the next video.